Okay, so now we can get to formally proving this statement here, the original code, by proving this statement here and then stitching everything together. So I've copied across the two logic statements that we proved, i.e. that it's strong enough to imply the postcondition and that it's weak enough to be implied by the precondition. And I've also copied across P and B, body of the code P, because we have to prove this as well, right? So I guess we'll do this part first. If I want to prove this, I've got 2 bits of code. I'm going to have to do the sequencing rule. So we split it into 2 parts. So I've got S is equal to I plus 1 on 2. And I is, you know what? No, that's fine. I is strictly less than N. And I less than or equal to N. And I is strictly less than or equal to N. First bit of code, I plus 1. And then mystery statement Q. Same mystery statement Q. S is assigned to S plus I. And then our postcondition. S is equal to I plus 1 on 2. And I is less than or equal to N. This is just P by itself. Okay? So I guess we do assignment rule backwards here. So I'll get S plus I is equal to I times I plus 1 on 2. And I is less than or equal to N. So this is true by assignment. Copy this same Q over. S plus I equals I plus 1 on 2. And I is less than or equal to N. Is this a valid form of the assignment rule? Doesn't look like it. Is it? No, it's not. Okay. So then we'll try do precondition, I beg your pardon, assignment on the postcondition backwards, like we usually do. So I have S plus I equals I plus 1 on 2. And I is less than or equal to N. Replace I's with I's plus 1's. So we get a big yucky statement over here. S plus I plus 1 is equal to I plus 1, I plus 1 plus 1, all on 2. And I plus 1 less than or equal to N. So this is true by assignment. I invite you to show that you can do precondition strengthening to get from here to here. So you should verify yourself. I'll do it in a different color. That S equals I plus 1 on 2. And I less than or equal to N. And I strictly less than N. If this is true, then this is true. So you should check that. S plus I plus 1 equals I plus 1, I plus 1 plus 1 on 2, and I plus 1 is less than or equal to N. It's a bunch of tedious algebra, but you have to do it. I'm going to assume you did it. I'm lazy, so I'm not going to. So then, what can we do? I can do 3 by assignment, 4 is logic, 5 is precondition strengthening by 3 and 4. 6 is assignment, 7 is sequencing by 5 and 6. And now I've got to somehow get from here down to here. So because I've sort of stacked the deck, so this thing's of the form P and B, code P, I can apply the while rule, right? This one here. So we'll do that. So I'm going to get, what am I going to get? I'm going to get P. So S equals I plus 1 on 2, and I is less than or equal to N, while B, so this condition here, because this B, that B match, so while I is strictly less than N, do the code, I becomes I plus 1, S becomes S plus I, and then our post condition is P and not B. So S equals I plus 1, and 2, and I is less than or equal to N, and this condition is false. So it's false to say I is strictly less than N. So by the while rule, 7. Okay? So far, so good. Now I just got to sort of wrangle this thing till it looks like this thing. And thankfully that's pretty easy to do because we got these two logic statements from before. So I can always strengthen my precondition by using this statement here, because this precondition is a stronger precondition than this one by line 2. So I can hot swap it out. I equals 0 and s equals 0 and n is greater than or equal to 0. While I strictly less than n, do the code. I'm just going to put s to represent all the code because I'm being lazy. But you should understand that s refers to all of this. Big S. Little s equals I plus 1 on 2, and I less than or equal to n. And it's false to say I strictly less than n. And fancy that. Now I can use post-condition weakening to weaken this post-condition to this one here. So 9 was pre-con strengthening by lines 8 and 2, 2 and 8. And then line 10 is going to be post-condition weakening by lines 1 and 9. And there we go.